Good afternoon, everyone, and welcome to panel 6. I hope you've had a fantastic Battery Day 2023 so far, filled with insightful conversations and plenty of networking. I'm going to be the moderator for this panel. My name's Jennifer Channel, and I am Commercial and Partnerships Lead for a startup based in the UK called Anaphyte. I'm also one of the Battery Associates Battery Ambassadors, and I'm also project director for the Volta Foundation's Battery Pub event. So really pleased to be joining you today and to be able to bring you this session. So this panel today, we're going to be talking about electrifying growth, battery value chain investments for gigafactories. I think we can all agree that we're going through a once in a lifetime revolution, moving from a high carbon combustion powered economy to a low carbon electrified economy. And with this comes the enormous challenge of standing up entirely new supply chains in places where they have never existed before. So we've got a fantastic lineup of speakers here today, and we'll be discussing all the necessary elements to establish battery supply chains, from investment to innovation, the role of automation to workforce development. So without further ado, let's get stuck in. So what I'd like to do is invite each of the speakers, after I introduce them one by one, to share their perspectives on battery value chain investments for gigafactories. So first up, I'd like to introduce Catherine He. Catherine He is an investor at TDK Ventures. She leads the research and landscape building in energy storage materials and battery technologies and technology scouting on startups in the energy sector. She is a published author with 12 peer-reviewed publications, 2 patents, and 1 book chapter. Prior to joining TDK Ventures, she was a battery researcher and engineer with 8 years of experience developing high energy density lithium-ion batteries and energy storage technologies. With a PhD in materials science and a deep understanding of technology, she was also trained by government and national lab programs in commercializing lab innovations. And additionally, she has had leadership roles in deep tech and entrepreneur communities. She is a founding member of the largest global battery community, the Volta Foundation, which includes more than 50,000 battery professionals. And she has also co-founded Battery Bits and Battery Street, and serves as an executive member of MIT CEO, which actively bridges academia, industry, and venture worlds to accelerate the clean tech revolution. So Catherine, I'd now like to invite you to the stage to share your perspectives on battery value chain investments for gigafactories.
Hi, Jennifer. Thank you so much for the introduction. And then great to see everyone here on Battery Day. This is a really great initiative. I think right now we're in a really exciting time and era that we're seeing all the electrification waves happening everywhere, in Asia, in US, in Europe. And I think right now throughout the battery value chain, there's a lot of investment opportunities. Basically, for us at TDK Ventures, we are 350 million CVC venture arm of TDK. TDK also owns 1 subsidiary in China, which is ATL, one of the largest battery manufacturer. So for us and also ATL, we have made a lot of investments from raw materials back to the mining, extraction, and then next generation for the silicon anode, and also new manufacturing technologies like dry coating. I think last panel, the speakers also mentioned the dry coating technology, and including the downstream recycling and all the applications on EV, on drones, on eVTOLs. So there's a lot of opportunities across the landscape of the electrification. There's so many segments to be electrified, not only EVs. There's a lot of heavy duty aviation and also everything that around us, from consumer to like, there's so many opportunities. This is an exciting era, and then hope to chat more with our panelists and with our attendance audience today to share my learnings in this space.
Thanks very much, Catherine. So next up, I'd like to introduce Pari Adeli. So Pari Adeli leads the batteries program at the Nickel Institute, where she applies her expertise and years of experience to ensure the performance of nickel-based battery chemistries is well understood. She also develops strategies for stakeholder engagement and sees partnerships to success. She is the host of Battery Chats with Parry, a series of online interviews with leading experts in the field, and a contributor to the Nickel magazine and the Chronicles blog. She developed the program and moderated the inaugural Nickel Institute Battery Day in June 2023 with more than 500 delegates from over 70 plus countries. Prior to this, Parry held a prestigious postdoctoral fellowship with the National Research Council of Canada, where she worked on energy storage material formulation and optimization, particularly on solid state and composite electrolyte materials. She earned her PhD in chemical engineering from the University of Waterloo. And Parry is the recipient of multiple awards, including the Merit Scholarship from University of Waterloo and the Nanotechnology Fellowship from the Waterloo Institute of Nanotechnology. She has authored and co-authored several peer-reviewed papers in the field of batteries in well-reputed journals. So Parry, please join us on stage if you could share your perspectives on battery value chain investments for gigafactories.
Many thanks, Jennifer, for the introduction, and also thanks to Battery Associates for the kind invitation. It's a pleasure to be here with the other esteemed panelists discussing this important topic. So global EV sales were at 10.4 million units in 2022. It's almost 60% higher than 2021. And looking at the 2023, according to several sources, is likely to see 14 million units of EV sales. There's clearly a growing need for electric vehicles, which increases the need for lithium-ion batteries, and that calls for more raw materials production. So to fulfill this energy transition, large investments throughout the supply chain will be needed. According to Benchmark Mineral Intelligence, globally, the battery industry needs to invest more than hundreds of billions across the whole supply chain to meet the expected requirements by 2030. As Jennifer mentioned, I work at the Nickel Institute, which is the global association of leading primary nickel producers. Thanks, Bears, for sharing this slide. You will notice a lot of familiar names on this slide. Nickel holds significant economic importance across many industries and applications. It is used in stainless steel, other alloys in the food industry, such as pots and pans, in engineering, buildings, transport. It's also used in electronics necessary in devices like your mobile phone. Nickel plays a critical role in emerging and future technologies such as electric vehicle batteries. In fact, batteries are the fastest growing market for nickel. So we have more than 300 million tons of known nickel resources. Most nickel produced in the past is still in service, and nickel enjoys high recycling rates and efficiencies. Currently, at current production levels of around 3 million tons per year, we can say that there is enough nickel for current and future generations. I know that there's a Q&A after the panel, so if Barris, you could go please to the next slide. Before I pass the floor back to Jennifer, I just must mention that the Nickel Institute abides by antitrust guidelines. We do not present forecasts or comment on nickel prices or supply demand. Glad to be here and looking forward to the rest of the discussion. Back to you, Jennifer.
That's great. Looking forward to hearing more of your insights during the Q&A, Parry. So next up then, I'd like to introduce Sam Phillips, who is leading in digital enterprise and services at Siemens Digital Industries in the USA. Sam was actually born in Worcestershire in England, and his career has spanned many aspects of the manufacturing industries and their value chains. He has a 50-50 balance between technology and operations and specializes in IIoT, Industry 4.0, 5.0, and digitalization strategy. Sam now lives in Michigan, having emigrated from the UK in 1988. Sam, welcome to the floor. Please, could you share your perspectives on investing in battery value chains for gigafactories?
Yeah, thank you, Jennifer, and hello, everybody. I will start with an apology, just in case my dog interrupts us. This is one of the benefits of working from home. You get to spend a little bit more time with your loved ones. So he's just coming back from the groomers, and he's sure to interrupt us. But yeah, this is an interesting time. the challenges that we're going to face, the digitization strategies, as I mentioned, I specialize in this area. And I want to go straight to kind of a reactive mode that happened with the UK government announcing that is now going to delay its new electric vehicle deployment plans by 5 years. So immediately we're going into reactive mode about how we can do this, how can we accommodate it. I think the challenges from a global footprint is that even though we have this made in America perspective coming out to retransfer business and manufacturing back to the continent, there is such a high dependency on a global market that that wave is still yet to come. But we also face the consequence of working as Siemens does on a global basis, thinking that we can simply repeat what has happened on different continents, and that is simply not the case. When you consider anything even down to the simplest specification of a wire color, we have a lot of complexities that are going to come our way. And the overall strategies of these plants, even if it's a 1 gigawatt per hour facility compared to a 60, we are in the billions of dollars to pull this off from a facility standpoint, let alone the infrastructure and the value chain requirements that we're going to get into. So it is quite a broad spectrum. And my only kind of first cut of this is that you cannot look at this in a siloed mentality. It has to be the value chain that we start to really analyze to make this work for the markets that we have out there.
Great, thanks very much, Sam. So I'd like to now invite our final speaker, Rory Francis Comiskey, who is president at Fusion IRX. So Rory is Fusion IRX president, an engineering consultancy firm focused on high-tech manufacturing sector from semiconductor, EV battery, and data centers. Rory is an industry professional with a career spanning 40 years and continues to be recognized for his ability to lead project teams from concept through to construction and commissioning by applying strategic thinking and problem-solving skills based on experience and industry BKMs. He's taken this knowledge and collaborated with strategic partners to develop training and innovative programs that emphasize pragmatic solutions to meet developing and dynamic shifts in the manufacturing and construction paradigm. Most recently, Rory's attention has been focused on addressing the lack of vocational schooling and training, which has left the industry in dire need of skilled trade craftsmen, automation, and robotics technicians. So Rory, a quote from Rory: "The immediate future of manufacturing and industry success lies in a dedicated focus on workforce development, utilizing a variety of means. Working with the numerous strategic partners, including the REC Foundation and Fusion IRX's in-house training group, he's turned his attention to developing the next generation of builders." And Rory also has a book that he is publishing, which will be available in 2024, that I would encourage you to read. So Rory, please join us and share your perspectives on investing in the supply chain for battery gigafactories.
Good morning. Thank you for having me. I'm very flattered to be here. I've been listening to a lot of the content this morning and really enjoyed myself. You made me sound old. I am in the industry 40 years. And at the core, I am a factory builder, predominantly in the tech sector. I started in semiconductor. The parallels between semiconductor, 30 years ago and the EV market today are significant. So I'm kind of reliving my earlier life. I've been involved in the EV sector for now about 9 years. I did have quite a few people on the first Tesla factory out in Reno. I do focus. So there are some issues, in the industry right now. There's just a tremendous amount going on in the EV sector and the high-tech sector, manufacturing sector as a whole. It's dynamic in nature. It's changing. It's hard to keep up with. And there's some great initiatives that are just picked up steam. But there's some constraints that need to be addressed too, and one of the constraints probably is the speed, how rapid things are changing and iterating, and evolving. We have a unique opportunity here right now as far as building manufacturing plants. Like I said, that's where I live and breathe. And right now, worldwide, there's something, and this number changes daily. I mean, I have to read constantly, and I'm researching every morning. That's what I do first thing in the morning. But there's about 276 manufacturing facilities planned or started worldwide right now, and the dollars and cents in the United States being pumped into efforts here are significant as well. So we have an opportunity right now, and I always say, to build better and to build faster and build just better factories that are more efficient, are just better neighbors to their local communities, leave a less of an impact, and actually, you use less power, you use less water, and they're addressing, the green initiatives that we have out there. So tons of opportunity. There are significant constraints, and I think we're going to delve into that a little bit later in the panel. But that's where I live and breathe. And yes, I do spend a lot of time in workforce development, and that is one of the biggest constraints to the revival of manufacturing in the United States and the EU. Not so much in Asia, but the parallels between what's happening in the EU market and the United States are fairly significant as well. So when you speak about one, I think you're really speaking about the other.
That's great, thank you. So I think we've touched on some interesting areas there already. We've had a nod towards investment and incentives. We talked a little bit about innovation and workforce development, and Parry highlighted the massive demand for EVs that's coming forward. So I wanted to pick up on the point that you made, Sam, around this isn't just a kind of copy and paste job. We do actually need innovation. I think that also speaks to some of the points that Rory was making about building better and building faster. So I actually wanted to ask Parry what her thoughts were on this, coming from a kind of an innovation background.
Thanks, Jennifer. So both approaches, I think innovation and, following through is have their own pros and cons. The copy-paste approach is low risk, cost efficient, when you do not have to reinvent the wheel, and you replicate what has already been proven in terms of technology. It enables a quicker transition to full-scale production. But then on the downside, it does not provide a competitive advantage in this very dynamic field where you have new announcements almost every week. Also, you could have a specific customer with a specific needs that compels you to be innovative. So I think that it is very important to continuously invest in R&D, especially in the cathode sector, and also, the advancements, let's say, in NMC battery technology as part of being a dominant chemistry right now in the EVs. I think the companies should decide with their project management team and conduct a strategic analysis in terms of timeline, budgets, customer needs, and decide on how much they can incorporate innovation and how much they can just use the well-established approaches and processing.
Thanks, Parry. So there's an interesting point you made there about risk that I want to pick up a bit later. But first, I wanted to ask Sam his perspectives on how can we actually get that competitive advantage, but also ensure that we are ramping up in the speed that we need to make to get to production scale and meet the demand.
Yeah, I think for me it's the old 80-20 rule. There is a lot of technology, a lot of lessons learned to come over here. The problem that I think we're going to get into is a couple of things. One, and again, not to get geopolitical on this situation, but the labor structure and the cost of technology, we're at a disadvantage over here. Maybe not so much with Europe, but definitely with our friends in Asia Pacific region. The whole context of education, training, I think, again, with Rory on this call, we are going to have to adopt and modify, again, the 80-20 rule, engineering that comes out of chemical, that comes out of food and beverage that comes out of application-based contexts, such as the BASFs, the Dows, the DuPont, etc. The processes run fairly similarly, but it's again, back to 80-20, we need really skilled engineering capability. And then we're going to have to learn through our colleagues in Europe, Asia Pac, the idiosyncrasies of the battery industry. Fairly recently, there was government information about over the next 7 years, on average, there will be 15 new battery plants being launched in the US. How we support that on a global basis, where we do not yet have a critical mass of equipment builders here. We still have specification requirements that are going to be modified that we have to adopt. The easiest way to do this is through, let's call it tribal knowledge or osmosis. But again, the incentive for these skill sets to come here and teach us in this world domain are not as strong as they used to be in history. So somehow we have to find a model, and this is not about we have all the solutions. This is about what are we going to face to achieve this output, this high productivity. One thing is automation, for example, but automation does not necessarily mean loss of work. It means a modification of roles within this. There is still this perspective of lights out production, but the engineering community has to be there to support it, but also move on to more of a controls and monitoring perspective. So in combination of technology, knowledge, and an adoption of controls and monitoring to higher the throughput and the yields, therefore more production generally means we can produce more at volume for less price. These are some of the models that we really have to evaluate as we go through this next year and the next 5 years. The technology will change. Lithium, we talk about lithium ion production. Well, this is not going to be a long-term, in my opinion, model for batteries. So are we able to kind of take a step function ahead of the industry by being the first to introduce the new technologies versus the latents of the current technologies in the other regions? This is innovation, and this is how we could actually accelerate our model for the business.
Thank you, Sam. And perhaps, Rory, you might also have some perspectives on this kind of interplay between getting up to production, automation, workforce development, given your kind of experience in the workforce development side.
Well, Sam's talking and my head is nodding the whole time in agreement. He made some very, very good points. So with the IRA Act, you know, there's a significant amount of funding for education, and the current administration is working with, I'm going to say ASU out in Arizona and several universities with programs, and they have a lot of promise. The problem with that is that's going to give us engineers in 3 or 4 or 5 years down the road. Our need is actually much more immediate. And on the technician side as well. And they're spending money in vocational training and great programs, and they will bear fruit in time. But our need now is immediate. There are some firms, and I can say Tesla worked with the Robotics Education Competition Foundation and STEM, and they actually built 21 labs in high schools, and that was to foster, you know, interest in robotics and automation. And they're actually taking interns directly out of high school, and it's a great program. There needs to be more of that. The heavy lifting, right? There's going to be a dire need for upskilling of our existing workforce, and the manufacturers and the Teslas and the Lucids and the companies of that nature, they're going to wind up doing the heavy lifting. There's going to be a lot of on-the-job training, internships and things of that nature to address the immediate needs. Those other programs, they're great. You know, Sam talked historically, and you know, I've written about it numerous times. In this country, in the U.S., there's a stigma about holding a union card and being a craftsperson or a technician, and we've pushed the 4-year traditional college model to the point that we don't have hands-on people to build these facilities, to maintain these facilities. It's a cultural thing. I think the culture, there's a slight shift in the culture right now, or people are talking about it a little bit more. That needs to be addressed. These are good, high-paying jobs where people can feed their families and be productive and contribute. And we've kind of lost that culturally. So a lot of work to be done there. It's not going to happen overnight, but I really think the preponderance of the work and the heavy lifting is going to be done by the actual factory owners and things of that nature.
Yeah, I think, just if I may, Jennifer, I think we're in vehement agreement, not disagreement on this thing. The whole mentality of this degree requirement that we have in this country, I think is creating a false barrier. And I think it's scaring people, actually. And I think the trades are critical. But again, this practical context of understanding process, understanding how things are done, is not given to you on a piece of paper. And I think if we could reintroduce the apprenticeships, the internships that we used to have that actually gave us a good grounding, I think this is an accelerator that the companies should be taking advantage of.
Yeah, I think with the industry being so nascent in the Western world at the moment, it's a very high skilled workforce that we've been working with at the moment. But actually, when you look at the proportion of people that are actually going to operate a gigafactory, about 50% of those are operatives. So they don't need to have a master's in engineering to do that. They need to have a hands-on apprenticeship that enables them to do that work. And when people think of a battery, they think of a highly complex system. So before we even think about getting people through this training, we actually have to attract people into wanting to do the training and to understand that there's a career for everybody within the battery sector. So what you're saying absolutely resonates with me. And before we go down a rabbit hole and talk too much about workforce development, which is close to my heart, I'd like to come back to a point that that Parry made and ask Catherine actually about this kind of coming a bit back to the kind of copy and paste versus innovating in the process, and the kind of the risk profile, and kind of wanted to get the perspective of an investor on this kind of approach. So do investors favor investing in innovative approaches versus kind of proven models that are going to get people up to production quickly?
Sure. I think I totally agree that for the whole electrification, energy transformation, we have to build faster and better. And then copy paste won't work from my perspective, because right now we just don't have everything that Asia has. For example, right now, the supply chain, in my perspective, like graphite, I used to think, okay, $10 per kilogram. But in China, their suppliers providing $2, even $3 of graphite, and also the laborers. So the laborers, I just come back from China 1 week ago. You will see the 20,000 laborers living in the plant dorms, and they are highly trained workers. We don't have that in US or Europe. And also all the know-how. Sometimes it's not just money can solve the problems. It's just 20 years, 30 years of accumulations on manufacturing, on each of the processing. And also for speaking of automation, I actually already seen the cell manufacturing line fully automated. You will see CATL, the Lighthouse plant in China. And then I saw the AGV robotics running in the plant, very smart, picking up the modules for cell charge, discharge, very, very advanced. So I would say that so first, I don't think there should be a competing like between Asia and US and Europe. I think it should be a collaboration, because something we can leverage the resources that are already been built and developed. And what most importantly, I think from an investment perspective, is that what will be the next? We have to do the diagram shift. So I think this is something that we really think need to leapfrog. So instead of what Asia is doing right now, building 2 football yard large gigafactories, hundreds of meters of roll-to-roll coating machine, how can we do for them using dry coating technology? much reduce the footprint, much reduce the carbon footprint, and also the space and also the energy consumption with only like basketball card smaller space, much less, 40% less energy consumption. And how about sodium-ion battery? Because lithium-ion battery, all the supply chain in US, in Europe, there's not much developed, either cathode, all the lithium from extraction, refinery, extraction. I think lithium resources are, China also doesn't have the advantage. But a lot of, from the cost perspective, a lot of new platform, I think we need to focus more. So that's why we're also looking at a lot of new chemistry that can enable the opportunities that for the industry to not, put everything, all the competitive resources only in one segment. And also looking at the policies. So looking at the policies, I was in Shenzhen in China, all the commercial vehicles are already EVs. From heavy duty to taxis, Didi, it's like Uber in China. Everyone is already driving EV. The EV, so the policy side, I feel like the Western world is also fall behind. And also the electricity, the people, I asked the drivers, why you choose EVs? Is that forced by the policy? They said no, because it's cheaper. It's cheaper just using electricity compared with burning gas. But the electricity in Europe is still so expensive. And then how can we deploy more renewables and energy storage to really enable the infrastructure to support the electrification is also important. So there's so many opportunities and so many, I would say, diagram shifts to think about what will happen in the next 10 years. What can we do to leapfrog? It cannot just copy paste. Even like in US, we see so many factories just, from LG, SK, they try to copy paste what succeed in Asia. In US, you will see a lot of messed up operation in the daily, operation. So I would say we have to be patient. We have to make a lot of money commitment and policy commitment from many angles. And opportunities are throughout the whole supply chain. This is exciting era, a lot of challenges, but so much more opportunities for us to look at.
Thanks, Catherine. Do any of the other panel members want to come in on Catherine's comments? Quite a lot in there.
Just a quick comment. I it's kind of natural to gravitate towards commodities that we can recognize, right? So the whole EV market, Catherine, it really is a fascinating situation. And I mentioned the UK stance now, and Toyota has taken a little bit of a different track as well. But this is why I mentioned holistically that we look at this, and Catherine mentioned the infrastructure. I'm not sure how many people realize that if you do have an electric vehicle and you want to go out and find a charging station, you may find one, but is the charging station working? We are actually producing batteries to charge batteries. So, this whole model of material supply for production is one thing. Can these countries actually support the planned deployment of electric is another question. And that's why, Siemens has been very fortunate. We're a big company. We've built plants in Asia Pac, in Europe. We're using our technology to bring it over here. But there's the other side of this government country perspective, which is, again, the supply chain, but also the infrastructure on the back end of it, and the recycling models, right? We produce batteries, not a very high yield from an industry standpoint. So then what do? This is this whole battery ecosystem that still has a lot of questions around it.
Thanks, Sam. Rory, did you want to come in?
I did, and going back to Catherine, Intel uses the phrase "copy exact," and they've never been 100% building one factory just like the other because it kind of just makes it easier and rote. That doesn't work right now with EV, and here in the States, it's all new to us, so we're kind of starting from scratch. I go back to build better, build fast. I was just reading an article, and it was a doctor out of somewhere in India was very interested, and he was kind of talked about smart manufacturing. And I've seen that material elsewhere, slightly different, a different vernacular, maybe different acronyms. And but he talked about Internet of Things, AI. He talked about the concept of digital twin, which is not, is something I'm very, very familiar with. But he came from strictly from a manufacturing standpoint, and I think that's kind of the problem. I build factories, right? So I come from a concept to building a factory, and in between that, there's and I've worked in manufacturing, I've worked in facilities, and I've actually worked, in the manufacturing end in my career. But you have three silos. You have building a factory, you have construction, and then you have the facilities group. And over here you have manufacturing, and they're all siloed, and they all speak. And I'm reading this paper, and I understood what he was saying, but it was in a total different vernacular. They're not speaking the same language. They're not talking to each other enough. If we're going to build smart factories, if we're going to build better, quicker, and have less of an impact, that we need to come together and call it smart manufacturing, calling plant as a product. But we need to integrate those things. In that paper, he was actually talking about sitting down and integrating and whatever. In my world, that's called an OPR, an owner's project requirements. So it's a start. I think that there's a lot of people talking about it. There's some inroads, but there's a lot of work to be done there. And like I said, it's a dynamic time in the industry. The next decade is going to be amazing. But if we really think this out and do it right, we can do it smart. We can bring down the cost per gigawatt that we're producing out of a battery factory. We can shrink the footprint and just really do some good things. The plant as a product or a smart factory, that transfer knowledge from one group to the next, it just makes it more efficient all the way through. And it incorporates the Internet of Things. It incorporates AI. And those tools are there, and they're readily available. And they're be honest with you, in my opinion, BIM and they're being underutilized. So if we can get these folks talking and work through this, I really think the tools are there. They're just underutilized at this point, simply.
Yeah, thank you, Rory. So we hear a lot about kind of, setting up gigafactories and the time that takes, etc. But Parry, I'm interested in your perspective on kind of higher up the value chain, setting up the mining and the pre-CAM and CAM facilities, if we're talking about cathode materials in particular. What are your kind of perspectives on what's needed to get that up and running as quickly as possible?
So there are multiple steps in setting up a gigafactory. So when you start the business planning, you have to work out basically, I guess, the capacity of your envisaged gigafactory. You have to look for a site that is, strategically located and it's close to that raw material supply, as you mentioned, and obtaining and securing that raw material supply is significant. And then you have to obtain the permits and be compliant with environment regulations, with safety regulations. And the other panelists mentioned, in terms of attracting talent for all the different departments, from the raw material sector to basically working in the cell manufacturing and providing a product. You have to purchase all these equipments for every department and set up for processing, and then the list goes on and on. Quality control, testing. So there's a lot of steps here, and I think that again, it's important that there's investments in R&D development and in every step of the way in advancing technologies for also, the raw material production section.
Thank you. And Catherine, coming back to you, is there, my understanding is the average time it takes to bring a mine online is something like 16 years. For a gigafactory, we're talking maybe a couple of years in this sort of pre-CAM to CAM manufacturing, somewhere in the middle of those. does that mean that there's a different risk profile? Like how do investors deal with this? And is there therefore more need for government incentives to de-risk certain parts of the value chain compared to others?
Sure. I think, again, there's a lot of role that technology can play on this paradigm shift. So we used to have this very lengthy from raw mines to your PCAM, CAM, all the extraction processing. But right now we are seeing a lot of technologies for some direct lithium extraction, which can, for example, we invest in one company called Novalis, can direct using the industrial waste CO2, which is another benefit of capturing carbon, industrial waste CO2 to directly convert lithium from the hard rock spodumene to the battery grade lithium carbonate. And then so it's shortened the time by almost 80% and also improve the efficiency. So we are looking at technologies that enabling like new ways of how we develop, because we cannot just wait. Right now, Gigafactories are built, but they're running empty. We have no supply chain, we have no cathode providers, it takes time to ramp up both the cathode and all the mining projects. We have to rely on new technology to innovate from extraction to refinery, and then to achieve a much greener, faster. So this is what we're looking for to how we progress to the next generation PCAM, and also recycling. So I really like Mr. Lithium, Joe Laurie. He said lithium is not a commodity. It is chemistry that it could or could not have the mining piece. So we can bring lithium back from black mass. So for example, US, we can import cells from China, from Korea, from everywhere. As long as the cells come to the US, it will be recycled forever for another 100 years. So recycling is another very important piece that can get much faster access of the raw materials instead of waiting for the long time lengths of the mining process. So recycling is also a very important area, and also direct recycling. Many segments in our recent years on the direct recycling. So new technologies can really change the game. That's our belief.
Thanks, Catherine. I think, what comes through strongly in everything that everyone is saying is that, innovation has a really key role to play in accelerating our ability to reach the production scales that we need to, but also to enable us to have the competitive advantage that we need. So I think this leads us nicely into the poll that Battery Associates have been conducting for this panel. So Mariana, I'm going to hand over to you to lead this.
Thank you, Jennifer. We have 2 questions and a poll. Then great. The poll for this panel was: which segment of the battery value chain do you believe present the most promising investment opportunities for Gigafactories? As you can see, battery cell manufacturing is the first. Then the second came to energy storage solution, and then raw material extraction and electric vehicle integration. Please, if you want to share some thoughts before we go to the Q&A.
Just an interesting thought, again, an opinion. It's interesting that chemistry did not come up as a key factor in this. And we talk about manufacturing, but I think going back to Catherine and Harry, this raw material situation and the actual chemistry involved is also something that I think should be paid close attention to. And I'm surprised that it didn't make a listing. Maybe it was just by the selection of 4 categories. And I'm wondering where that falls within these 4 categories.
Yeah, makes sense. Some. It's really important also. Makes sense. Yeah, maybe Rory, you can mention the cell manufacturing is the first. Do you agree with that?
Well, from a selfish reason, yes. And I have been a little involved in actually work. Fusion is actually on 3 or 4 recycling. unselfishly and trying to be objective, cell manufacturing, sure. It's, well, from a business perspective, it's the biggest dollar value you're going to see. It's where the biggest investments is going to be. For me, it's the biggest opportunity. So I'm working on making these plants more efficient. And for me, that's where the biggest opportunities are. But dollar value, that's where the biggest investment is. So yes, I would have to agree with cell manufacturing.
Great, thank you. Anything else maybe about raw material extraction? Yeah, the last time, maybe, Perry, please.
I think that when it comes to batteries again, it's such a dynamic space, and the answer to this question with the bullet points can change and relies on a lot of factors. Earlier, Catherine pointed out a specific country, so manufacturing can shift from current leaders to other economic leaders. And other factors are advances in technology and, the government policies and incentives that can impact whether it's, cell manufacturing or raw materials extraction. But looking at the numbers, the first three seems to be close to each other. Generally speaking, you don't want bottlenecks in any step of the supply chain from mines to gigafactories. Yeah, that's my opinion.
That's great. If you think so, we can go to the questions from the audience. Then there are two, as I mentioned. The first from Sabina Dov. It seems like a lot in the US battery manufacturing is taking place in southern states. How will the union play a role in this upskilling workforce? Who wants to take that?
Mariano, if nobody objects, I'll take that. So I live in the Southeast, and it's been referred to as the Battery Belt, and it as far north as Tennessee and runs as far south as northern Georgia, and we're currently on 5 or 6 projects there. Tremendous amount of work. So a couple of things. In the Southeast, the unions aren't quite as strong as they are in other places in the United States, so it's not that huge of a factor. But I'll be honest with you, this administration and companies are reaching out to the unions and asking for their help on it, and they need to play a role in it. I actually wish in the South they were a little stronger for that reason. But they are reaching out. Again, like I said, they're not quite as strong there, but nationwide, besides the Southeast, that's part of the initiatives and some of the funding that we're seeing being funneled into that in vocational training. So obviously, they have apprenticeship programs that are established so we can upscale and build on existing programs and tailor them. And that's where manufacturing needs to come in, and we actually work with the unions and tell them what specific needs they have and skills they want to see. So some hand holding between manufacturing and the unions would definitely be helpful. The battery belt is booming. It keeps me busy, keeps me up late at night.
Great, thank you for that, Rory. Then we can go to the next questions because there are now 2 more. Then from Roger Atkins, give the significant cost and challenge of energy for gigafactories. Are likely to see more innovation as vector in North French, who will use in recuperated industrial waste heat? Who wants to take that?
I can comment very quickly. I think it's a great question, Roger. This sustainability model, right? Again, we use the term green, usually about the end product, but not so much about the process to get to the end product. It's a fascinating topic, and when companies say they're going to be carbon neutral or zero carbon, it's based on where they stand today. It's not a reality to say there is going to be no carbon production. But again, this to me goes back to the processing, the chemistry involved I mentioned before, and how we can actually turn this into a kind of autonomous system through the production to recycling back into the system, etc. I think the reusability aspect of what we work with from materials is going to be a critical element to get there. But it is of high consideration. But I don't always think that everybody gets the "we are green" mentality, or there are loopholes to saying we are green that need to be closed?
Okay, thanks very much. So unfortunately, we've run out of time for questions. Before we end, I'm just going to ask each of the panel members to give me one keyword for this panel. So not even a full sentence, just one word that you think is really important to this topic before I hand back over to Battery Associates to continue with the event. So starting with yourself, Parry, what would be your keyword for this session?
I guess massive capital deployment for Catalan.
It's a few keywords, but we get the idea. It's capital. Okay. Sam, over to you.
If I can have two words, just based on everything that the world knows about this, the continuous improvement is critical.
Great. Over to you, Catherine.
I would still say focus on innovation and paradigm shift. That's the most important thing from my perspective.
Thank you. And finally, last but not least, Rory, yourself.
Collaboration. One word. Collaboration.
Great. So we've got massive capital deployment, collaboration, paradigm shift, and innovation. And sorry, Sam, I've forgotten yours already.
Continuous improvement.
Continuous improvement. There we go. Okay, so thanks to all of our panel members. It's been a pleasure to moderate this session this afternoon. If you want to continue the discussion, I'm sure there's plenty of further networking sessions. So I'm going to hand back over to Battery Associates. Over to you guys.
Thanks very much, panelists. That was brilliant, and a great conclusion to the panel as well, with the one or few words. So now it's time for the deep dives. So we've got a selection of 4 deep dives for you guys to choose from. Deep dive 4 is sodium-ion batteries. Deep dive 5, battery cycler, with members from the Battery Associates team. Deep dive 6, BEV or FCEV electric trucks. And deep dive 7 is battery manufacturing engineering, dynamic ecosystems, aggressive ramping, and rapid scaling with Siemens. So we really encourage you to be as interactive as you can with those questions, get them into the chat function, and the moderators will help surface those to the speaker. And it'll take about 30 to 35 minutes. So see you over there.